Bismillahirrahmanirrahim. Welcome students. Today we will continue Article 2.4 Terms Associated with Motion. We will discuss speed, velocity. We will learn the differences between speed and velocity with different examples. Speed and velocity have different meanings. Speed, being a scalar, refers to how fast or how slow an object is moving. It can be thought of as the rate at which an object covers distance. In the picture, the fast-moving body has high speed as it covers a larger distance in short time. Slow-moving body has low speed as it covers small distance in same time. For example, the man is running at 2 kilometers per hour and a man is walking 0.5 kilometers per hour. In same time interval, the distance is different. The running man is covering a distance of 2 kilometers, whereas the walking man is covering a distance of 0.5 kilometers. We are talking about the speed of a running man and a walking man because in speed we consider distance and time only. However, velocity, being a vector quantity, refers to rate at which an object is changing its position. When evaluating velocity, we must keep in mind the direction in which the object is moving as well. So a man is running at 2 km per hour towards east is actually defining the velocity. The man is walking 0.5 km per hour towards east is again the velocity. Let's get familiar with the terminologies of speed and velocity. First, speed. Rate of change of distance is speed. Whenever we use the word rate with any physical quantity, it means we are describing the change of that physical quantity with respect to time. It is represented by small letter v. V is equal to d by t. It is a mathematical formula that you can use to calculate speed, where v is equal to speed, d is equal to distance, and t is equal to time. In previous classes, you might have used capital S for distance as well, which is also correct. Its unit is meter per second, or m is -1. It is a scalar quantity because it only requires magnitude. For example, a person driving a car at 100 km per hour is speed. So 100 is a number, kilometer per hour is a unit, which adds up to magnitude. A cyclist who covers 30 meter, it is a distance, in time 2 seconds, has speed of, you can use the formula v is equal to d by t, so 30 by 2 is equal to 15 meter per second. That is the speed of the cyclist. Let's get familiar with velocity. The rate of change of displacement is velocity, or change of displacement with respect to time is velocity. Small letter v, but bold because it is a vector quantity. Similarly, small letter d, but bold because displacement is a vector quantity too. So the mathematical formula to calculate velocity is v is equal to d by t, where v is equal to velocity, small d, displacement, and t, time. It is represented by v, but you can also use a bar, a cap, or an arrowhead because it is a vector quantity. And vector quantities require magnitude as well as direction for their explanation. Its units are meter per second, or ms-1. A person driving a car at 100 km per hour in southeast direction is its velocity. So in this example, you can see 100 km per hour is the magnitude and southeast is the direction. That is why we are saying that it is the velocity. So if a body covers equal distance in equal intervals of time. It is traveling with uniform speed. And if a body covers equal distance in equal intervals of time in specified direction is said to be traveling with uniform velocity. So the difference between speed and velocity, uniform speed and uniform velocity, is only of direction. The magnitude, however, remains the same in both cases, that a body is covering equal distance in equal intervals of time. A car is moving from city A to city B. The car covers a distance of first 5 meters in 2 seconds. Then again the next 5 meters in 2 seconds. Then again 5 meters in 2 seconds. Same distances are being covered in same time intervals, 2 seconds, 2 seconds, 2 seconds. Using the formula for speed, distance by time, you can calculate the speed at each interval. 5 by 2, 2.5 meter per second, 5 divided by 2, 2.5 meter per second, 5 by 2, 2.5 meter per second. It means the car was traveling with a uniform speed of 2.5 meter per second. And since there is no change in direction of motion, thus velocity will be equal to magnitude of speed. So in this example, the motion of car was uniform throughout the journey with respect to speed and velocity. If a body covers unequal distance in equal intervals of time, it is traveling with non-uniform speed. And if a body covers unequal distance in equal intervals of time, but in specified direction, it is said to be traveling with non-uniform velocity. So again, if you see the magnitude, at unequal distance in equal intervals of time, unequal distance in equal intervals of time. However, non-uniform speed does not require direction. Over here, velocity involves direction. So again, a car moves from city A to city B. It covers 5 meters in 2 seconds. Next, it covers 12 meters in 2 seconds, 20 meters in 2 seconds, and in next 2 seconds, it covers a distance of 25 meters. So the time interval remains the same, 2 seconds. However, there are unequal distances, 5 meter, then 12 meter, 20 meter, and 25 meter. If you calculate the speed at each interval, here using the formula S is equal to, speed is equal to distance by time. So 5 meter by 2 is equal to 2.5 meter per second. Over here, 12 divided by 2 is equal to 6 meter per second. Here, 10 meter per second. And over here, 12.5 meter per second. It means the car had varying speed or non-uniform speed. And since there is no change in direction of motion, thus magnitude of velocity will be equal to magnitude of speed and varies along it. So in this example, the motion of car is non-uniform throughout the journey with respect to speed and velocity. However, non-uniform velocity can result not only by the change in magnitude, but also by change in direction and change in both magnitude and direction. For change in magnitude, the body should cover unequal distance in equal interval of time, as discussed in previous example. For change in direction, the body should cover equal distances in equal time interval. However, the direction would be different. For example, let's consider a stone that is tied to a thread. When you tie a stone with a thread and reel it, it will start moving in a circular path. The string will try to keep the stone moving in a circular path. The stone, however, will try to move in a straight path. The blue dots over here represent the stone that is trying to go straight, but the string is applying the force on the stone and is trying to keep it in a circular path. Here the direction of stone, it wants to go towards the north, but the force applied by the string on the stone is compelling the stone to keep moving in a circular path. Again, at this point, it wants to go to the west, but the force applied by a string on the stone compels the stone to move in a circular path. Again here, the direction is changing. Over here again, the direction is changing. Now the speed is same, but since direction is changing, so we will say that the body is moving with non-uniform velocity. Let's see the third case. When there is a change in both speed and direction, consider a rectangular path. Suppose you start from this point and move 3 meters towards north, then 4 meters towards east, then 3 meters towards south, then 4 meters towards west. And suppose during this journey, the time that you took was 10 seconds. So every time your magnitude will be different. Over here, 3 by 10 is going to be a different value. Over here, 4 by 10 is going to be 0.4. Then again, over here, magnitude is going to be different. And over here, magnitude is going to be different. And direction, over here, it's north, east, south, and west. Since the magnitude and direction both are changing, it will result in non-uniform velocity. Average speed is the distance traveled over the total time taken. Average velocity of object does not tell us what happens to the object between the starting or ending point. What happens to the velocity of object at the starting or ending point. Consider you're walking around a rectangular path. Again, you walk 3 meters towards north, then 4 towards east, then 3 meters towards south, then 4 meters towards west. The time taken for this walk is, let's say, 30 seconds. So you will find the total distance first, 4, 3, 4, 3, add them up. You know the total time. We just did a supposition that it might be 30 seconds that took us to travel along this rectangular path. We will use the formula average speed is equal to total distance by total time, where my answer is going to be 0.47 meter per second. So now you can easily understand that this is going to be the actual value 0.47 meter per second. This value is not giving us any idea of what happened between the starting and ending point. When calculating average velocity, you are looking at displacement over time. Since you walked full rectangular path and ended up exactly from where you started, that is this point. So your average velocity is going to be 0 meter per second. If you even look at the direction of vectors, it is in this direction, this 3 meter is in opposite direction, they both to cancel out, then over here it's 4, then again it's opposite direction, they also cancel out, so it all adds up to 0 as well. These are the differences between speed and velocity. Speed, the rate at which an object covers a certain distance, is called speed. Velocity can be defined as the rate at which an object changes position in a certain direction. The formula for speed, v is equal to d by t, simple letters. Formula for velocity, v is equal to d by t, where v and d are bold letters as they are vectors. Speed is a scalar quantity, velocity is a vector quantity, speed non-directional, velocity has direction. The average speed will continue to count even if the object changes direction. However, in velocity, the object changes the velocity of object changes with change in direction. Therefore, the object must follow one direction. Speed can never be zero, velocity can be zero. An example of speed, the sports bike traveling at 50 meter per second, just the magnitude. And when you talk about magnitude with direction, it is velocity. Your home assignment is you have to revise the lecture. You have to write the difference between speed and velocity, and you have to write notes on speed and velocity. Many students are finding it difficult to write notes on speed and velocity. So there's a little bit of hint of how you can write a note on speed and velocity. You have to write the definition, then notation. Notation means the representation, like small letter v or um, small letter v bold. Then you have to write the formula, how to calculate the speed, then unit for it, quantity, what sort of quantity is a scalar or vector. Then you can give an example. Then you will write the speed of velocity, and if you're writing a note on types of speed, and if you're writing a note on velocity, then you will write types of velocity. Uniform speed, you will give the definition and example. And non-uniform speed, definition A, B is the example. Average speed, again definition and example. You have to follow the steps in writing a note on speed and velocity. I hope you got the lecture today. If you still have any problems, you can discuss it with me. You can call me or you can text me on my WhatsApp number shared in group. See you in next lecture, girls. Allah Hafiz.